Good morning, professors, and welcome to an innovative experiment conducted with the Wacebo ScienceBus. In today's scientific experience, we will explore how to effectively utilize a voltmeter to accurately measure the voltage across a battery. To successfully conduct this experiment, we will require the electricity kit. Specifically, for this scientific experiment, we will need a voltmeter and cables that have cylindrical connectors at both ends, a crimson-colored cable and an ebony-colored cable. Then, we will necessitate cables that possess an alligator clip on one extremity and a cylindrical connector on the opposite end, one of which should be crimson-colored and the other ebony-colored. Subsequently, we will require the 1.5V circuit battery along with additional batteries that exhibit varying levels of charge. During this experimental procedure, we will observe the method of utilizing the voltmeter to accurately measure the potential difference across these batteries. The voltmeter is outfitted with a black terminal which functions as the negative terminal alongside a 1.5V terminal and a 15V terminal. As a result, the pair of red terminals will allow us to measure two separate voltage ranges. In the situation where the voltage we aim to measure is expected to attain a peak of 1.5V, we will utilize the 1.5V terminal for this task. On the other hand, if the voltage we are planning to measure is anticipated to reach up to a peak of 15V, we shall employ the red port designated for 15V. Following this, we proceed to insert the cylindrical connector of the red cable into the 1.5V terminal. In a similar manner, we insert the cylindrical connector of the black cable into the negative terminal. Now let us proceed to establish a connection by attaching the black alligator clip to the negative terminal of the battery. Then we proceed to attach the red alligator clip to the positive terminal of the battery. After doing so, we observe and document that there is no observable increase in the voltage level. The needle of the voltmeter remains stationary at 0 volts, indicating that the battery is entirely discharged. Let's proceed by measuring the voltage level for another battery. We take a 1.5V battery, so the terminals will remain unchanged. We connect the black cable to the negative terminal of the battery and the red cable to the positive terminal, and we observe how the needle of the voltmeter indicates a voltage level very close to 1.5V, which is the nominal value of the battery. Now, let's proceed by utilizing a 9V battery. In this particular scenario, the red cable needs to be inserted into the 15V terminal. Subsequently, we connect the red cable to the positive terminal of the battery and the black cable to the negative terminal of the battery. In this specific instance, the needle of the voltmeter indicates a potential difference of approximately 7.5 volts, which is noticeably different from the nominal value of 9 volts for the battery. This discrepancy is due to the fact that the battery has already been used. Let us conduct the experiment once more by employing an alternative 9V battery. We proceed by connecting the leads to the positive and negative terminals of the battery, and this time we observe that the voltmeter indicates a potential difference of approximately 10 volts. This occurs because the battery is fully charged and has not been used previously. Professors, thank you. We will see each other at the next experiment. Goodbye.